is the chapter we did like ratios and proportions and similar triangles and all that good stuff, right? No, I never give a multiple choice test.
I swore it was multiple choice.
It is not, and it was not, and it will not be. It'll look like this, okay? It'll look just like these tests, all right? Here we go. So it says tight end scored 6 touchdowns in 14 games. Find the ratio of touchdowns per game. The word per means to divide by, and it says reduce the fraction. Okay, I told you exactly how you should write this. Yes, sir. So it says find the ratio. Ratio is a fraction. We're going touchdowns per game. So how many touchdowns? There's 6. And several people miss this. This is unbelievable. Anybody would actually miss this. Per game. And how many games were there? There's 14. Some people just left it like this. But what is... So what does this say?
I mean, he is asking what he did.
It says, well, I'm in the middle of telling him. Why does he ask when I'm in the middle of telling? Okay. It says reduce the fraction, so you must reduce it. 2 goes into both of those. 2 goes into that 3 times into that 7. So that is the only acceptable answer. Well, you could have written it like this. You could have written the ratio as 3 to 7. That's the same exact thing. All right, but it has to be a 3 and a 7. All right, that's the only acceptable answer. Absolutely, because that's the instructions. Instructions say. I know, I'm answering your question. So it says reduce the fraction, so you must reduce the fraction to get credit for that. All right, here we go. Solve each proportion. We're going to do a lot of this kind of stuff later on in the test, but this is just real simple, basic, straightforward cross multiplication. We've been doing that a lot in here. So we cross multiply. So I like the x on the left-hand side. You don't have to, but I like it. So we go 5x equals 2 times 40, which is what? 80. And then you divide both sides by 5. What's that, 16, I think? All right, and then that's it. All right, this one's just the same kind of thing, but there's one little twist to this that you do have to distribute. That's exactly what the twist is. All right, so you got to make sure. I always put that in parentheses right there. So if you distribute, now you could distribute right then and there, but I'm going to write it out just so everybody sees what we're doing. So it's going to be 2 times x plus 1. I put that in parentheses because that means I'm going to distribute. And then equals 3 times 7, which is 21. Okay? Go ahead and distribute. So it's going to be 2x plus 2 equals 21. Subtract 2 from both sides, you get 19. 2x equals 19. Divide both sides by 2. So just write your answer like this. Just write it, 19 over 2. There's no reason to put that into a calculator and get a decimal, because the only thing that can come of that is you mess up and put it in your calculator wrong and get the wrong answer. All right, just leave it 19 over 2. It's already reduced. You don't have to change it to a mixed number. Just keep it 19 over 2. For some reason, a lot of students at this stage in their math career just have a hard time leaving an answer as an improper fraction. But when you do algebra, and this is basically an algebra problem right here. When you do algebra, sometimes, a lot of times, it's just as good or it's better just leaving it as an improper fraction. Okay, it's less work. You want less work to do, and so I'm trying to make less work for you. So don't even put it into a calculator. Just leave it like that. Now, if you did put it into a calculator and you put the right answer, I would accept it, but you don't need to. All right, let's move on. Find the measures of the angles of a triangle. Find the measures of the what? The angles of the triangle if the ratio of the measures of the 3 angles is 5 to 4 to 7. Let me scooch this over so I have room to write. All right. So the measures of the angles of a triangle, and the ratio is 5 to 4 to 7. Does that mean one of the angles is 5, the other is 4, and the other is 7?
No.
Of course not, because what do all the angles have to add up to be in a triangle? 180 degrees. So 5, 4, and 7, there's no way that adds up to 180 degrees. But this represents 5 times a certain number. This represents 4 times that same number and 7 times that same number. So how are we going to write that? 5 what? X plus 4x plus 7x equals what? Right, it's because it's the angles of the triangle. That's where we got the 180 from. Because remember, this 5 times x represents one of the angles in my triangle. This represents the second angle. This represents the third angle. They all add up to be 180. And now you just do the math and you solve. Now, when you just solve for x, is that your answer? No, because it says find the measures of the angles. So we need to find actual 3 angles. All right, so let's do this. 5 and 4 is 9, and 7 is what? 16. X equals 180. Is that 5? Yeah, because we just did it, didn't we? 180 divided by 16. Just make sure. Oh my goodness, that's not 5. It's 11.25. What was I thinking? Oh, I was thinking 80, not 180. Right. So 11.25. That's why it's good to check. So what is it? 11.5. Is that my answer, though? Do I circle it and say, "Hey, I'm done"? No, it says. Was it 2.5? I can't remember anything. All right, it is 2.5. Yeah. All right, 11.25. Sorry about that. Yeah, and you plug it in. You plug it in where? Into this one, and into this one. So you're going to get 3 angles because it says find the measures of the 3 angles, doesn't it? Right there. Measures of the 3 angles. That's what you want to find. So it's 5 times. You can do that on your own. Okay, I'm not going to do this for you. 5 times 11.25, 4 times that, and 7 times that. You'll get 3 of those answers, and that would be your final answer. We good? All right, let's take a look at number 5. This is the same kind of deal. Except it's not angles of a triangle. What is it? It's the measures of the what? Of the sides. All right, so look what we have. Do I go 3x plus 5x plus 7x equals 180 again? No, because we're not talking about angles of a triangle on this one. We're talking about the sides, and the sides all add up to something. That's what the perimeter means, right? All the sides add up to be 450. So it's basically the same problem, isn't it? Except you add it up to, you set it equal to 450, right? So what do I get? I get 3x, and I'll let you do the math on this, plus 5x plus 7x. These are sides of a triangle. Don't set them equal to 180 because they're not angles. Okay, they add up. The perimeter is 450. That means all 3 of these sides add up to be 450. You can do the math yourself, okay? I've given you the answers, right? When I gave you the test, even if you got it wrong the second time, I wrote the right answer next to it. So you add them up. And then divide by whatever that is, and you get a number, and then you plug them back in, just like we did this one. All right, so very, very similar to number 4, except this is perimeter, and this is the angles of a triangle. We good? All right, let's take a look at this. Remember, this chapter is about similar triangles, so if you take a look at this, these are actually similar triangles. Look what I have. I've got a 40 and a 1 arc angle. I've got a 40... I've got a 40 on a 1 arc angle right here. And let's see, what else? That's all I need, isn't it? If I know 2 angles of one triangle equal 2 angles of another triangle, that means that these 2 triangles are similar to each other. All right? So it doesn't tell you right off the bat that they're similar. That's something that you had to figure out on your own. So they are similar. So big deal. So they're similar. Well, what can you do if they're similar? You can set up a proportion. Okay? You can see things that correspond to each other. So let's do this. Let's compare. Let's do it like this. Let's compare this side to this side. Everybody see that? So what am I going to compare? I'm going to compare 6 to what? 12. Now if I compare 6 to 12, what does that reduce to make things a little easier for us? 1/2, 1 to 2. All right? Now watch what I did. How do I know which ones I compared? Well, I compared the 6. How do I know which one over here corresponds to the 6? Well, I can do this. Look, this 6 is across from this angle with no arc on it at all, right? You see it? This doesn't have any arc on it, but 6 is across from it. Look over here. What angle doesn't have any arc on it? Angle F. Which one is across from angle F? X minus 3. So the 6 goes with what? The X minus 3. You see that? Yeah? Can you what? Yes. All right, so what we're going to do is we go 6 to 12, and then we're going to do what? We're going to go x minus 3 to what? 12's opposite the 40. What's opposite the 40 over here? The x plus 1. So I'm going to compare them like this. Do you see it? So if I go 6 to 12, I have to go x minus 3 to x plus 1. I could have done it several different ways, all right? There's a lot of ways you could have set this up. It will all, if you do it right, they'll all come out the same answer. I could have gone 6 to 12, and x minus 3 over x plus 1. Or I could have gone 6 to what? Over here. To x minus 3, and then that would equal what? 12 to x plus 1. You cross multiply, you'll end up with the same thing no matter how you do it. You could have gone the right side to the left side, couldn't you? All right, if you wanted to. I could have gone x minus 3 to 6 and x plus 1 to 12 if I wanted to. Everybody understand that? All right, there's all kinds of ways you could have set it up, but they'll all eventually come out to be the same thing. Let's do it how I was going to do it. 6 to 12, or 1 to 2, right? Equals, what was it? X minus 3 to x plus 1. Cross multiply and you're good to go, right? So you multiply that, that's just x plus 1. We'll just distribute this, is that all right? 2x what? Minus 6, right? Subtract x from both sides, you get an x over here. Add a 6 to both sides, x is 7. And that's all they ask for, isn't it? Make sure that you read the instructions. On that particular one, it just says solve for x. There could be problems where it says find the length of ED, so you'd have to plug it back in, wouldn't you? Everybody understand that? All right, so make sure that you read the instructions and you find what they are actually asking for, because they don't always just ask for x. Look at this. They ask for actual measures of sides, don't they? So make sure that you read what they're asking for. Okay. Let me get rid of this stuff. Just clean it up a little bit. Okay. And let's try a different color. All right, what else we got? Number 7 says find the perimeter. Well, we talked about perimeter earlier. It just means you add up all 3 sides, right? That's what a perimeter of a triangle is. But look what they do here. They don't give any pictures or anything. They do give you this. And that is really important. So let's use that thing. It says triangle ABC is similar to DEF. That means AB corresponds to what? DE. You follow that? All right, so that's really going to help you because they give you all these little sides right here. You don't really have to draw out the triangles. They give you everything you know in that little similarity statement, they call that thing. I'll scooch this over. Give me some room to write. All right, so let's see what we can do. Let's see. Find the perimeter of DEF, correct? So I know all 3 sides of the one triangle. So the triangle ABC, I know AB, I know BC, and I know AC. What don't I know? Well, let's see. What else do I know? I know one of the sides of the second triangle, don't I? I know DE. So what am I going to have to find? I'm going to have to find the other 2 sides, aren't I? So I know DE. I'm going to have to find what? EF. And what else am I going to have to find? DF. All right, you see that? So that's what I'm going to have to find. So how in the world am I going to do that? Let's set up a little scale factor. What does DE correspond to on this triangle? DE corresponds to AB. So let's set that up. You see that? Those correspond to each other. So I'm going to go 15 to what? 5. And what is 15 to 5 if I reduce that? It's a 5. I said 15, even though it looks weird. It's still... So that bothers you so much. I'll change it. There. Is that better? So 15 over 5 is 3 to 1. All right, so that means every side on triangle ABC is what? 3 times as big as every side on triangle DEF. You with me on that? All right, so I know one of my sides is 5. So on triangle DEF, I know one of my sides is 5. So DE is 5. All right. What are my other sides on my triangle DEF? What else do I have? I got EF I need to find, right? And what else do I need to find? DF. All right. Once I find these 3 sides, then I can add them up and I got the perimeter. So what about EF? What does EF correspond to over here? BC. So what was BC? It was 18. So that means this is 3 times as big as EF. So really, what can I do? I could set up a scale factor if I wanted to, but this is an easy one. Just divide it by 3, exactly right. So if this is 18, I just divide it by 3 and I get what? 6. So EF is 6. You see that? Because BC and EF go together. BC is 18, so EF is 1/3 as big as this. All right, so I just divided by 3. What about DF? DF, this is the first and the third one. That's the same as AC, isn't it? AC is 21, so how do I find DF? Just divide it by 3, right, which is 7. So now what do I do to find the perimeter of this triangle? So if I want to find the perimeter, I'll write perimeter. Just add them up, right? 5 and 6 and 7. What's that? 11 and 7 is 18. And so that is that. Does it make any sense? You know what you could have done too? You could have added all three sides. You could have found the perimeter of the triangle ABC and then done what to it? Divided by 3. Exactly right. So you got that answer down. I'll use you all the time for that one. All right, so you could have added them up, couldn't you? And then divided by 3, and then you've still gotten 18. It would still work out. So there's a couple ways you could have approached that. That's just the way that I did it. That's just how I was thinking. All right, let's do another one. Let's do number 8, RT. Let's go a different color here. Let's go this blue. All right, we got to find RT, this thing right here. Oops. Well, you see it. I was going to make it X, but that's already X. Let's call it A. Is that right? So instead of calling it RT, we'll just call it A. What's that? Did I change it? I don't know. What did I put on there?
Change it to RV.
Oh, did I?
RT is that long side.
Yeah. Okay. If I changed it, then I mean you can still find RT, but I just made it a little easier for you. So what did I ask for? RV. Okay. So since that's what I gave you on your test, I'll go ahead and put that in there. So let's just find RV then. Let's do this. Let's set up some scale factors. I want to find RV, which is this whole entire left side over here. I could do a couple things. I could compare 5 to what? X, or I could compare 5 to what? 4. But if let's say I did it this way. If I compared 5 to X, what would I have to compare over here? 4 to 8. Now look at this. This works out actually pretty easy because this 8 is how much bigger than this 4? It's twice as big, isn't it? So this must be what? Twice as big as this, right? Because it's the same scale factor, right? So the scale factor is 1 to 2. The scale factor here is 1 to 2. You could set the whole thing up if you wanted to. Watch. You could go 5 over X equals 4 over 8 and cross multiply and go through all this. But if you understand really what's going on and what it means to be in proportion, this works out a lot easier for you. Look at this and you say, oh, this segment is twice as big as this. So this one is twice as big as this. So what is X equal to? It's equal to 10. All right. And you could have done this. Watch. 4X equals what? 40. Divide by 4X is 10. Right? You could have gone through that, but wasn't it easier just seeing that this was twice as big, this is twice as big, boom, it's 10, you're done. Would you agree? All right. If you understand what's going on. Oh, that's not RV though, is it? That's just this. That's just that. What is RV then? From here all the way to here. It's 15, right? Because that's 5 and that's 10. You add them up, so RV is 15. We already found SV, right? We did SV first, to tell you the truth. So SV was 10, and then there you go. You right with that? So that wasn't that bad at all, was it? It's pretty easy. All right, what about this thing right here? Let's go different color again. Let's go the deep purple. Deep purple. I used to be at rock group back in the 70s. Did you know? Deep Purple. So I didn't really listen to them, but I know it was a group. All right, so here we go. We want to find Ln, which is this X plus 3, and Pn, which is this X plus 1. So basically, we want to solve for X, don't we? So let's scooch this over a little bit. So we want to solve for X. We got similar triangles here. It's because of angle, side, because these two angle. All right, so you've got these two. These are parallel lines, so this angle, it's kind of ugly. Let's do that again. This angle and this angle are equal to each other. So they're similar triangles, okay? You probably don't really care to show that they are similar triangles. You probably just want to do the problem. So let's do the problem. We got to set up some kind of scale factor, don't we? Look at you could do it again. You could do it a couple different ways. You could compare 4 to what? X plus 3, or you can compare 4 to 3, right? Does that make sense? Let's compare 4 to 3. Is that all right? So if I compare 4 to 3, that's my scale factor. Because 4 is opposite this vertical angle, 3 is opposite this vertical angle. What about the X plus 3 and the X plus 1? It's pretty obvious how you compare them, I think. This is opposite the 2 arc angle, and this is opposite the 2 arc angle. So what am I going to put on top? X plus 3 over X plus 1. We've already done this a couple times already in this test, haven't we? cross multiply, but what do you have to remember to do here? Yeah, put parentheses and distribute, okay? I'll let you do that yourself. All right, so you cross multiply. It's going to be 4x plus 4 equals 3x plus 9. You do the math. I think you can handle that part of it. Is that what it is? X is 5? Okay. But does the problem say to solve for x? Problem says to do what? Solve for ln. So would you say x is 5 on this? Okay. So if x is 5, ln, right, is 8 because it's 5 plus 3. And then pn is just 6 because it's plus 1. Easy as that. We good? Questions? All right. What about this crazy stuff? Mid-segment. What in the world's a mid-segment? Well, mid-segment connects the, what? Mid-points. It connects the midpoints of two sides of a triangle. So this little X right here is a mid-segment, and this, yeah, that, why do I even have that in there? I don't even know is that what it is? Okay, I don't even know I have that line in there. But watch. What's true about the mid-segment? The mid-segment is half of the opposite side, right? The one that's parallel to it. So this is just half of this. It's 15. That's all there is to it. Easy, isn't it? All right, so the mid-segment of a triangle is very easy. It's just half of the base, I guess, if you want to call it that. I don't know what else I can say about that. That was pretty simple. What about this one? This is just as easy, isn't it? My goodness, it's almost the same exact problem. So look, this is the mid-segment right here. That's half of this. So this must be what? 18. Right? Of course, I could have given you, that's probably what I should have mixed it up a little bit. Maybe I did on the next one. If that's 18, then you could just take half of it, and that's 9. I think that's what I did here, isn't it? Yeah, this one's really easy. And you're just solving for x again, aren't you? Now watch, if this is 8, remember this is a, what? It's a mid-segment, isn't it? These two are mid-segments, so it hits right here. So if this is 8, what's this? That's 8, the whole thing's 16, so this is what? 8. Piece of cake. Wow, this test has been pretty easy so far, hasn't it? You must have all got hundreds on this, I guess. Summer didn't even get 100 on this. Oh, look at this one. Oh, you said you did? Oh, I thought you said you didn't. Oh, there was one you didn't get 100 on? Good. All right, let's take a look at this. This is a good one to work out. It's not hard to figure out how to set it up. It's really pretty easy. Look what we have. It doesn't even say it's a mid-segment, but you know it is. Why? Because it splits this into two equal parts. Do you see it? So how do I solve for x? This has 2 arcs, this has 2 arcs, so what do I do to solve for x? Just set them equal to each other. That's right. Okay, they're both exactly the same, so you just set them equal to each other. Now, it's easy to figure out that you set them equal to each other. The fraction is probably what bothered you a little bit on this for some of you. So let's set them equal to each other. I'm going to put the bigger number on the left-hand side. It's just a little nicer that way. 1/5 x plus 3. It's not that difficult. It's just a matter of finding a common denominator. You could do this a couple different ways, but this is how I would like you to do it, okay? Or I think it's the best way to do it, tell you the truth. I have to get the x's on the same side, don't I? So I have to get rid of this 1/5 x. How do I get rid of that 1/5 x? Right, it's all being added, isn't it? That whole 1/5 x. I'm not just trying to get rid of the 1/5. I'm trying to get rid of the 1/5 x. It's being added, so I subtract it. So that's going to cancel out here, but I have to subtract it from here, right? Let's do this, though. Let's find a common denominator. Let's write 4, the number 4, so that it has a denominator of 5. So what over 5 is equal to 4? 20, right? 20 over 5. Would you agree? So that's all I did. And why did I pick 5 as a denominator? Because the thing I'm taking away from has got a denominator of 5. Make sense? So what I'm going to do, let's write it over here. I'm going to write 20 over 5x minus what? 1 over 5x. What's that? What's 20/5 minus 1/5? It's what? It's 19/5. And again, we talked about this earlier. A lot of people freak out a little bit when they see these fractions like this, especially if they're improper. I'm telling you, the next step, when you do algebra, many, many times, I'd say most of the time, it's better to have an improper fraction, and it's easier to work with an improper fraction than it is a mixed number, right? But for some reason in elementary school and lower middle school, to the other side, right? And what do I get over here? 38. Now, the reason it's nice to have this as an improper fraction is because now I can get rid of that fraction very easily. Now I want to get rid of just the 19 over 5. I don't want to get rid of the x. I want the x to stay where it is. So how do I get rid of a fraction if it's being multiplied? I multiply by the reciprocal. So I come over here and I multiply that by 5 over 19. Now they've rigged this thing, haven't they? So it comes out nice and even. That cancels, so x, I don't know if you knew this or not, but 19 goes into 38 how many times? How about twice, right? So 2 times 5 is 10. Now, is that what they asked for? To just solve for x? Absolutely. They say just find x, so x is 10. All right? Make sense?
Yep.
It's not that hard. What was the hardest part about this? Was changing that 4 into a 20 over 5. That was the hardest thing. But you all know that 20 over 5 is 4, right? Right? Just common denominator stuff. We should have a whole entire year where you just learn how to add fractions. Find out. I think it's going to take a year. At least a section, okay? And you really should. I mean, that should be... for some reason, fractions aren't taught the way they used to be. I mean, I remember when I was a kid, man, they pounded fractions into us, and that was good. At the time, I didn't like it, of course, okay, just like you guys, all right? But after, doing it a long time, and after I learned how to do it, I found the benefits of using fractions. I know what you're going to say. Well, we got calculators. Why do we have to do that stuff? But it's good to know things. It's good to know about numbers and how they interact and how to work with them. Okay, you can't just rely on calculators and machines for you all the time. It's nice to know things. It's nice to know why things equal what they do, not because of a machine. I didn't do this one, but this one's, I'm not going to do this for you. What do you do with these? Set them equal, and then the math is really easy. Okay, that's a lot easier than the x. Okay, so I'll let you do that one. This is just about as easy. We'll finish this whole test today. How about that? Look at this. These two segments I told you are equal to each other. So what do you think I'm going to do to solve for x? Set them equal. Okay, very, very easy. All right, it just is the most, it's like the simplest Algebra 1 problem you could probably do. All right, so you solve for x, there you go. Now what about this? They didn't tell you that this segment and this segment are equal to each other, but you know that they are. We had a theorem that said, now you don't have to memorize a theorem or anything, but if you have parallel lines and these two segments right here are equal to each other, that means these two segments are going to be equal to each other, even though it wasn't marked. It wasn't like I forgot to put it in there. Okay, these are automatically going to be equal to each other. So what do? You set them equal, solve for y, and you're good to go. Easy, right? What about this one? Now this one you're going to have to set up a little proportion. Let's take a look at this. We had a theorem that said if you have a triangle, I forget exactly what it said, but if you have two angles of one equal two angles of another, and I forget exactly what the theorem said. I'm trying to think of what it said, but you don't care anyway. Because if you have a situation like this, watch, if you have a situation like this, these things are in proportion. So you can set up a proportion. How do you think you can set it up? You can set it up like about 4 different ways. You could compare 2x plus 1 to what? To 40. Okay, if you want to go that way, you can. All right, compare this one to this one, but then what would I have to compare over here? This one to this one. You see that? Or I could have gone what? I could have gone 2x plus 1 and compared it to x plus 4. And then I had to go 40 to 25. It doesn't really matter because when you cross multiply, you're going to end up with the same thing anyway. So let's see what we get. We get 2x plus 1. How are we going to do this? We're going to compare that to 40, right? Equals what? So if I compare this left side to the right side, I'm going to compare the left side of the little one to the right side of the little one. And now we've done this about 4 or 5 times already just in this one test, haven't we? Cross multiply. So you make sure you distribute, put it in parentheses, put this in parentheses, distribute, blah, 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 solve for x. You can do the rest. You do the blah, blah, blah. Okay? It's not too hard, is it? I don't think it is. All right, this one's a little tricky. Now watch this one. You watching? This one's just a little bit trickier. This is just one triangle, and you've bisected this angle up top here. And what it says, this theorem says something about it breaks these sides in proportional to these two segments, all right? So I could compare what? I can compare 20 to 30. But what am I going to have to do here? I'm going to have to compare this side, which I don't know, to what? To this segment right here, which is y. But what about this? I circled nothing here.
Come on, guys. You can do it.
28 minus y.
Very good.
Very good.
28 minus y. Because if you knew this, let's say y was 10. What would this segment be right here? Be 18. How'd you get that? You went 28 minus 10. But you don't know it's 10, do you? But you do know it's y. So how did you get this segment? You went 28 minus this segment right here, which is 28 minus y. So let's set this thing up. So now we're going to set it up like this. So we're going to go 20. Now you could have set it up, you could have gone 20 to 28 minus y and then 30 to y. You could have done that way if you wanted to. It would still work out the same. When you cross multiply, it'll still be exactly the same. But let's do it like this. 20 to 30 equals what? 28 minus y to what?
Y.
To y. Right. Now watch, to make this a little bit easier, 20 over 30. Why don't we reduce that just to make our math a little easier? 10 goes in both of those, so it's just 2 to 3, isn't it? And you cross multiply. What do you have to do to this 28 minus y, though? Make sure you put in parentheses and distribute the 3. And I'll let you do the rest of that. We got a couple minutes. Let's just do it, okay? So let's do the 3 first. So it's 3 times 28. I don't know what that is. What's 3 times 28? 84. Okay, so I've got 84 minus what? 3y equals 2y. Add 3y to both sides. I get 5y equals 84. It's not going to come out even. I could keep it 84 over 5 if I wanted to. If you really, really wanted to, you could put it into the calculator and you get 16.8. All right. All right, but I would accept that. I'd be perfectly fine if you kept your answer like that, okay? And if you wanted to write it as a decimal, you could. Look at that. We went through the whole entire test, didn't we? All right. So we only have one more test to do, and it was your last test, right? It was Chapter 8. So tomorrow we'll go over Chapter 8. That's that trig stuff, law of cosines. So I doubt we'll get through the whole test in one class period tomorrow. So probably what I'll do is this. Listen, are you listening to me? What I'll probably do is this. In my 5th period class, I'll probably go through the first... Listen to me. Yes. In my 5th period class today, I'll probably go probably about half of the Chapter 8 test. All right? I'm not going to cover that with you guys tomorrow. So what I'll do with you guys tomorrow is probably do the second half of Chapter 8 test for you guys, okay? But what if you don't know the first half of it? Go to the 5th period class on YouTube, watch that video, and then I'll show you how to do it on there, okay? So your whole review will be on there, but sometimes I went over it in class, sometimes I didn't. Like yesterday, yesterday on Chapter 6, we only got through, 7 problems? Well, we did the rest of that test in 5th period yesterday. So go to the 5th period YouTube, watch it on there, and everything will be on there for you, all right? Again, the final is going to cover these same type of problems. It's going to be 40 problems, so it's not going to be every single one of these. It'll probably be close to that. I tried to break it up pretty even, all right? So that's what's going to be on there. It'll be 40 problems. It'll be just like a regular test, except you don't do corrections. Okay? Yes. I have been, yes.